Welcome to another episode of Progress, Potential, and Possibilities, discussions with fascinating people designing a better tomorrow for all of us. I'm your host, Ira Pastor.
Welcome, everybody, again to another episode of our show, bringing in another really awesome guest today involved in creating a better tomorrow on some really unique fronts. Today, we have the honor of being joined by Dr. Michael Roberts, who is Chief Science Officer of the International Space Station National Laboratory and Vice President at the Center for the Advancement of Science in Space, which, as manager of the International Space Station National Lab in partnership with NASA, is responsible to the nation for ultimately enabling access to the ISS for research, for technology development, STEM education, and ultimately commercial innovation in space as a public service to ultimately foster a scalable and sustainable low Earth orbit economy. Before joining the Center for Advancement of Science in Space, Dr. Roberts worked as a microbial ecologist, principal investigator, and research group lead in the NASA Advanced Life Support Program at the Kennedy Space Center. And prior to that, he completed his undergraduate degree in biology at Maryville College. He did his Ph.D. in microbiology at Wesleyan and did postdoc work at the Center for Microbial Ecology at Michigan State University and the RIKEN Institute in Japan. A lot of really interesting topics and themes to get into today. We're honored to have him with us, Dr. Michael Roberts. Thank you so much for taking the time out of your schedule to come talk to us for a little while.
Well, thank you, Ira, for the opportunity to speak with you today and get some more information out there about the awesome job that I have the good fortune to support.
Outstanding. Yeah, I mean, I'm really looking forward to this, Mike. I would love to start off. I enjoyed reading all about you and everything you've been doing up to now, and then obviously before the space station. Take a little time just to introduce yourself in terms of your sort of the microbial ecology background, because I was looking at some of your papers and all sorts of interesting bacillus species you focused on in your PhD, and then for a good decade or so you were looking not just at waste in space, but all sorts of interesting things we could do to either reuse that waste or destroy it or turn it into something else. Take a little time and tell us a little bit that background story, if you would.
Ira, thank you so much for that kickoff. It's a dangerous job you've given me here because I hate talking about myself, which means I'm going to go on and on for an hour now.
That's okay.
Going back in time, I entered graduate school last century, back in the late 80s, early 90s, and became interested in microbial ecology a little bit later in my college career. I had always had an interest in ecology and microbial evolution. Microbes have the good fortune of having been with us here on Earth and predating us by several billion years. So they've had a lot of time and opportunity to explore different ecological systems, different niches. So from the perspective of a person who's interested in ecology and evolution, it's an interesting group of organisms to follow. That way they've had a lot of time to play and figure things out there. And then as I was in graduate school before the turn of the century, a lot of the tools that are commonplace now were just coming online. So polymerase chain reaction, the ability to amplify DNA molecules from individual organisms or from whole populations, were just coming online. Researchers were just beginning to understand the power of utilizing DNA as a means of understanding diversity and even getting to questions about function in different environments. So one of the things we've always been limited by in the microbiological world is our ability to culture organisms from different environments. We can do a pretty good job with the organisms that live on us and within us. So, since the time of Pasteur, we've kind of figured out causes of disease, but we haven't been able to capture even, a small percentage of all the diversity that's out there. So DNA gave us a tool in order to do that. So all of that came together in my mind and seemed like, hey, this is something cool to go do. So I was fortunate enough to find myself at Wesleyan University with a new starting faculty member there, Dr. Fred Cohen, who had began his life as an evolutionary biologist looking at Drosophila fruit flies, and then had seen the light that bacteria were even more numerous and reproduced far more quickly, and had been involved in evolutionary processes for even longer than these fruit flies. So he switched over to bacteria. So under his guidance, I was able to complete my thesis work on Bacillus subtilis, as you mentioned, which I'm sure is a topic which is near and dear to the heart of literally 5 or 6 listeners out there. Bacillus, from my perspective, though, is a very interesting organism. It's a spore-forming organism, so it can hang out in the environment for long periods of time as a spore. Yep. And be very resistant to UV damage and other things like that. So all of that kind of naturally led into the opportunity to do a post-doctoral research position with the Center for Microbial Ecology at Michigan State. That group was interested in the behavior of microorganisms who could provide benefits to humanity. A lot of the microbial world has the ability to break down compounds that we have contributed to the environment, which can cause us harm, one of those being polychlorinated biphenyl compounds, PCBs. Sure. So I had an opportunity to take my curiosity about microbial evolution and ecology to Michigan State University and the Center for Microbial Ecology to do work there. And that led to an exchange program with researchers from Japan. So Japan sent some researchers to Michigan State. A few of us had the opportunity to go work in Japan for a couple of years and study how these microorganisms who had, for the first time, encountered PCBs and other related compounds in the environment, they don't naturally occur, how they had been able to evolve the chemistry to survive in environments that were full of these very toxic compounds and actually break them down into substrates, compounds that were less harmful to the environment, and then provided us ways to remediate the environments and get them out. So yep. I was able to do that, learned a lot there, had an opportunity to then come to Kennedy Space Center and work with a group that was focused on technology development, focused on environmental control and life support. So everything that we currently do in space on the International Space Station is based on physical chemical systems. We have to recycle air, water, and recover as much of the energy as we can. We use solar power in space for the most part. And since water is an absolute necessity for human life, it has a significant downside into that it has a high mass. It weighs a lot. Each gallon of water is a little over 8 pounds. So it's at a premium in order for humans to live and thrive in space, to be able to recover as much of the water as you can. Unfortunately, we don't have the ability to put a wastewater treatment facility on board the spacecraft. So we use physical chemical means to do that, to recover as much of the water as we can. But the research I was involved with in the group at Kennedy Space Center and a couple of other of the NASA field centers were focused on biological approaches. They were actually looking at ways to bring biology into spacecraft, or probably more appropriately, habitats on the surface of other celestial bodies, to accomplish the same things with recovery of air and water and treatment of waste that we do with the physical chemical systems. So anyway, that's my history in science. That's kind of how I got here. I still like to read the literature and keep up with microbiology as much as I can, but as an older man now, it's difficult to keep up with all of all of the great science that's going out there in the microbiological world.
Yeah, no, but it's still an interesting connection. And obviously, when we talk about things later, like about radiation resistance, or as you mentioned, the extremophiles and all their amazing abilities, interesting to sort of feedback to that. But I just wanted to sort of lay the groundwork about who you were, because it is nonetheless a pretty cool 20 years there that you were doing that stuff. So anyway, you end up in this amazing position, and I think as most people maybe not are aware, that a couple hundred miles above us right now there is a space station above your head right there, and maybe less so they don't know about all the interesting things that are happening on it in terms of science and engineering and so forth. Talk a little bit, if you would, about, well, first, sort of just the NASA ISS CASIS relationship. I know there's been sort of been back and forth in terms of how the space station is currently managed, and a little bit about sort of the research mission per CASIS versus NASA, because I know some of the folks who had on the show on NASA, right? I mean, they're thinking about these moon and star shots, how we get back to Mars and beyond and so forth. You're doing a lot of stuff that's more near and dear to what's happening on terrestrial side now. So walk us through a little bit of that, if you would.
Yeah, and it's all related. Not to correct you, but it's CASIS. It's
Sorry.
An acronym, Center for the Advancement of Science and Space. So there is actually no correct pronunciation, but in the house here, we call it CASIS.
CASIS, perfect.
So the International Space Station, as I'm sure you're aware, and your audience knows, has been with us for going on 23 years now. So it's been an incredible engineering accomplishment, not only for NASA and for the nation, but more so than I think than any other spacefaring program that we've had. It has involved the participation of international partners. So it's a significant accomplishment simply for that purpose, in that we were able to have the support of investigators and engineers from 16 different nations involved in the design and assembly of this facility in low Earth orbit, where it's been operating continuously with crew for over 22 years now, going on 23 years in November. So it's been a very exciting journey for all of those nations and the spacefaring programs within them in order to establish that facility. It was designed with multiple goals in mind, but foremost among those was understanding if humans could live and work in space in low Earth orbit, and overcome the challenges of living there for extended periods of time. It's been very successful in that. We've also, through the years, understood and been able to explore new technologies for maintaining a human presence in space. I talked a little bit before about environmental control and life support.
Yep.
We utilize the International Space Station not only as a place to live and work and actually perform cutting edge research, it's also a test bed. You can take new technologies up there or improvements to existing technologies that enable humans to live and work in low Earth orbit and start thinking about long-term habitation on the moon and even Mars and beyond. So a lot of those technologies that are going to be employed as we move farther away from Earth are going to be tested and developed in that environment. And the International Space Station continues to play an extremely critical role for NASA and our international partners in that aspect. We've also, over time, learned that it has multiple uses beyond that. So it is a destination now, right? So we have, for the first time in human history, commercial transportation systems which take not only cargo, but take crew members back and forth to space. And that has opened up brand new vistas of technology development and new markets and new opportunities for industry to become even more involved in space than they have been in the past through the development of communications and Earth observation satellite systems like that. So it's always been a very vibrant ecosystem in space since the 50s, but it's grown tremendously just over the 20 plus years of International Space Station existence. Where we're going now and in the future is even far beyond that, in that the International Space Station now serves not only the purposes of those spacefaring agencies, but we've learned that a lot of the research and technology development that we are engaged in space has benefit that directly translates to common problems here on Earth. We've learned a lot through the years. NASA's learned a lot through the years about ways to mitigate the effects of living in a microgravity environment on the human body, the way to keep the crew healthy in that free fall environment. Everybody has a good time once they overcome the motion sickness part of it and get their vestibular systems right. But that starts to wear on you over a while being in that free fall environment. Your bones and muscles don't quite know how to respond to that lack of loading that you get in that environment. They start to deteriorate. In devising ways to make effective countermeasures for that, some of which involved exercise, some of which involved changes in diet, some of which involve the use of therapeutics. We've also learned that some of those conditions mimic what we see here on Earth as we age. Our bones and muscles weaken as we age. So we are now able to take advantage of that. So those similarities between what's been going on with astronauts and crew members for 50 years now, we're able to translate those discoveries into biomedical research discoveries that have direct benefit here on Earth. And that was always part of NASA's goal, was to spin back some of these technologies. But now we are purposefully inviting other research communities to take advantage of access to microgravity so that they can directly ask questions of interest to them. So you were asking about how the International Space Station National Laboratory interacts with NASA itself and the International Space Station. So our portfolio is slightly different than that of NASA's for research and technology development in that most of NASA's research, as with the other space agencies, is focused on understanding our planetary systems. And for crewed exploration, they're trying to understand how to maintain crew health and safety and design vehicles that can reliably get them to their destinations and return them safely. So a lot of it is focused on exploration goals. Our research and technology development is simply focused on using space as a tool, as a lever, if you will, in order to better understand fundamental science, understand ways that we can leverage space to perhaps improve our lives here on Earth. In short, to benefit humanity. So our portfolio at ISS National Lab is slightly different than that of NASA's and aligns very well with what the National Science Foundation does here in exploring the fundamental nature of living things and the fundamental nature of physics and matter in the universe. It aligns very well, our portfolio aligns very well with the National Institutes of Health, who have the mission to improve health here on Earth by understanding how to prevent disease, how to track the onset and progression of disease, how to mitigate the ill effects of disease, and essentially prolong the healthy phase of all humans on Earth going forward. So in taking that slightly different viewpoint, we have also been able, through the creation of the National Laboratory, open up access to new communities of researchers. So previously, much of the research, if not all of the research in space, was funded by NASA or one of the international partner agencies. Now there are other government agencies which are also funding research and technology development at significant levels in that environment to address questions that are of primary importance to their particular missions. So in addition to National Science Foundation, National Institutes of Health, we've worked with some different programs within the Department of Defense focused on human health related issues, different programs working on the design of new materials, advanced materials that can offer improvements in combustion engines and basic design. And that type of research, again, it runs the gamut from fundamental discovery research that National Science Foundation funds typically to more applied types of science that are of interest or maybe of interest to the Department of Energy. Industry, for example, has obviously worked with NASA and the space program for many years, but there's been a significant increase in direct funding, projects that are directly funded by the private sector through industry to begin to use access to space to further their own goals. So the International Space Station, I think, has been a very significant investment of time and resources, time, treasure, and talent, not only here. We're actually starting to see a lot of that pay dividends now in opening up these new vistas. If it were not for what we've been able to learn on the International Space Station over the previous 23 years, I don't think we would be in the position we're in to actually begin talking about settling on the moon and establishing a gateway there. We wouldn't be we still have some work to do, obviously, as a species in getting to Mars and living there, but we're far closer now than we were before. And then on the more unexpected, I think unanticipated side, it's driven new economies, new markets, and that's one of the areas that we're seeking to expand with National Laboratory, is to continue to engage with the private sector to build and offer new services there. So space tourism is a real thing now. You can get up to space and experience the overview effect for yourself. We're also working very closely, not only with NASA, but with several other U.S. government agencies to begin to explore manufacturing in space. That early stage interest in the performance of different materials and the response of biological systems in unique ways to that persistent microgravity environment have led to some discoveries that can improve processes of manufacturing here on Earth. Specifically from the life sciences side, looking at areas involved in tissue engineering and regenerative medicine, use of induced pluripotent stem cells. These are all things that are of great interest here on Earth, and in some cases, the technologies are getting close to clinical application, but they're not quite there yet. And microgravity has an important role in offering some new ways to accelerate the pace of discovery, so that we get to where we want to get for their use and application here on Earth even faster than we could were it not for them.
It's so interesting. Again, you're talking about the portfolio and obviously mentioning things like stem cell research and 3D printing and obviously the whole spectrum of drug discovery, development, what have you. We've had people on the show that involved in some of these projects that are your partners to talk about just the joy of this particular part of their research. People like Pat Verdun at Colgate-Palmolive, and again, I guess we're all getting back to microbial ecology here, but talking about sort of unique microbiome stuff in the mouth that you have to take into account. I saw you published a little while ago with my buddy Mike Levin up at Tufts on planarian regeneration and all the weird things that happen there in zero gravity. Obviously you have a couple hundred projects there, which I'm sure you're excited about all of them. Give us a couple more examples that that you can talk about, obviously, along these lines, because we're obviously very focused on the life sciences. Any specific projects, demonstrations, whatever, that are like, wow, this really stands out as a major hit for us, that you might not think about it, but wow, we learned that in space, and now we're going to bring it back down here and
excellent question, and I'll pick up. I appreciate you asking that question in a different way. I'm often asked, can you tell us what your favorite experiment was in space, or your favorite finding like better than the other one? And you really can't answer, because they're all different and special in their own way. But we have examples where another, in addition to Colgate-Palmolive, for example, Merck Pharmaceutical. Merck has been involved for a very long time in space-based research. A lot of that interest early on was driven by the ability to grow large protein crystals in microgravity that have advantages for imaging back here on Earth. So the whole prospect was you have a candidate molecule which you think could be useful to treat a certain disease, but you need to understand its physical structure. You need a really good roadmap of what it physically looks like in order to better inform, hey, is this going to work for the particular task I have it? And are there ways that I can perhaps modify it or change it to make it even more effective in combating the disease or the physiological effect that I'm concerned about, or make it less prone to cause toxic side effects, which is always a concern with oral drugs like that. So
Sure.
Merck has been interested in microgravity for a long time and performed a series of experiments that in fact blazed the way for improving the way we do protein crystal growth environment. And a lot of it, most of that work early on was focused on growing these larger crystals for imaging. So in the grand scheme of things, that drug discovery focus is early in the drug discovery pipeline. That's where you think you may have a molecule that's interesting, and you're getting all the information about it that you can before you proceed with testing it against model organisms, and then hopefully getting up to where you test it in clinical trials in real humans. But that process going from the early stage drug discovery to actual clinical applications can be 15, 25, 30 years in some cases, and can be billions of dollars in cost for the pharmaceutical companies and for the government sponsors of that research who are interested in seeing significant outcomes. More recently, we've seen Merck and other pharmaceutical companies become focused on access to microgravity for a different facet of that, and that's looking at ways to improve the formulation of FDA-approved drugs. So Merck has within its inventory now an immune therapy anti-cancer drug called Keytruda.
Yep.
Merck has looked at the active pharmaceutical ingredient in Keytruda and its crystalline form when precipitated in the microgravity environment versus what they get here on Earth. And they've discovered that they can get an improved size distribution of it. So doing that crystallization step in microgravity led to a discovery that, hey, there may be ways to tweak the way we formulate this drug that have benefits here on Earth. And those benefits, if they're able to get to recreate that here on Earth, they'll have the opportunity to eliminate some of the purification steps they have to do as they're making the drug. That drives down the cost of getting that drug to market. It also makes it far more amenable to long-term storage. It's not, it is by its very nature a large molecule. It's a monoclonal antibody. But if you can get a more narrowly distributed dispersion of sizes of the nanocrystalline state, it makes it easier to store, which makes it more appropriate for use in nations that may not have the infrastructure, right, to support clinical settings where you have to deliver the drug. Mm-hmm. Most importantly, it also improves the safety and efficacy of the drug if you have this rather uniform size distribution. So that was an unexpected outcome from Merck's research. It wasn't something they set out to do, but by sticking with it and seeing some benefit from the research they were doing in space, it led them to this discovery, which has not only beneficial possibilities for Keytruda in the future, it's actually led other companies to start pursuing similar tasks. Are there ways that we could take drugs that are currently within our inventory and are either FDA approved or nearing FDA approval, but we're seeking ways to improve their manufacturing process that we use for it? That's opened up brand new vistas. We've seen similar outcomes from the advanced materials side as well. There's now a significant interest in growing funding from the public sector for semiconductor manufacture in the space environment. So those are real world advantages where in some cases, you may only be able to replicate the beneficial aspect of the manufacturing in microgravity. Maybe you actually need that as the secret sauce to do it. But while they're getting there, each of these companies are also learning something about the process they didn't know before that hopefully they'll be able to recreate back here on Earth. Because at the end of the day, it's always going to be far more economical to do these manufacturing processes here on Earth than it is in space, simply because the transportation costs have come down tremendously over the past 10 years, but it's still the ticket to get to space is still a little bit pricier than most people want to pay.
Mm-hmm. Mm-hmm. Like what is the process for? I mean, so here I am, Ira Pastor, pharmaceutical company. I got an assay that I want you to do up there. I don't just show up at the Kennedy Space Station and throw it on on the next ship. There's a whole, I got to, from what I remember, I have to, obviously there's proposals and things that go on, but there's a lot of work that goes on, training on what the process is going to be here first. Then there's a series of missions that are scheduled well in advance that has to go up one. I know they have one actually coming up soon. Walk us through that a little bit and how the whole process works for anyone, whether I'm a biotech company, a material science startup, whatever the case may be. How this all works for someone like myself or my organization.
Yeah, certainly. No, again, excellent question. And it all begins really with a conversation, right? So you have an idea, you have a thought that perhaps you have a question that could benefit from access to the space environment. In some cases, it's access to that microgravity environment. In some cases, it may be that you have a sensor or a material that you want to test in the harshness of space, or you want the ability to utilize the orbital path of the International Space Station treated as a satellite so that you can look back at Earth or look into deep space from that orbital inclination and get some idea about it. So it really all just starts with your idea and a conversation, either with ISS National Laboratory or with NASA or with any of the multiple implementation partners and commercial service providers, these commercial companies that have expertise and services. In some cases, they actually own and operate the hardware of the facilities in space. It starts with a conversation with them. The change there has been that in the past, if you were coming from the corporate sector, especially industry, you needed to have a conversation specifically with someone at NASA or one of their international partners. And that conversation essentially had to be tied to some program that existed there, right? There had to be some interest from NASA or that international partner in your technology, your area. You couldn't, for example, buy access to a rocket then to go do your test. All that's changed now. So you have the opportunity, if you want to continue to work with NASA and partner with them. They certainly have exquisite expertise and wonderful state-of-the-art facilities that can benefit companies from across the many sectors of industry to do that. But you don't have to. If your market is not to sell back to the government what you're trying to do, you have the opportunity to work directly with other businesses that may have similar interest to you. So if you're a company that's involved in making tissues for transplant, and you believe that there's an advantage to taking your cells to space and having them assembled there are companies that operate bioprinting facilities on orbit. So you can start a conversation with them directly about how would I get to space. If you already have that expertise in-house and you simply want to find out how to fly it, right? How to get it. I've got a bioprinter and I've got my cells and I think I can do something great. There are companies out there you can talk to that will help you fly it, figure out how to make it safe and transportable to microgravity. It's not just limited to the International Space Station, right? As we start to transition towards the year 2030, the International Space Station will be approaching its end of useful life around 2030, maybe slightly after. So there are already plans and designs and actual hardware space station, and those have a variety of different design and operating modes in mind. Some of them will be crew tended, the way the International Space Station is. Some of them, like a recent test performed by a company called Varda, is simply based on flying an uncrewed platform, which has a small manufacturing facility on board. So it goes up into low Earth orbit, stays for 30, 45 days, however long you need it, and then it returns back to Earth. And then you go open up the capsule and get your manufactured product out of it. So, for the first time in human history, you have this ability to, as a business person, as a member of a not-for-profit institute who's interested in finding cures or treatments for particular diseases, you have the opportunity to go and talk directly to service providers, to companies that can get you to space. And in many cases, it's beneficial to have NASA and ISS National Lab in that conversation, but we don't have to be there. There are more direct commercial ways for you to do that. So in essence, the opportunities for getting your ideas up to the space environment and testing them are multiplying, I would say, almost exponentially. Every year that we get closer to transition, 2030, slightly thereafter, there are more and more companies coming online with different opportunities, different platforms, different ideas and thoughts about how to get to space. Everybody is for sure at some point pursuing kind of the same market. Everybody is seeking to find a way to do it more economically than we've done it as a nation, and it certainly takes government funding at very high levels to get to space and land on the moon and maintain an international space station operating for 20 plus years in low Earth orbit. But in the future, companies will be able to afford that, and individual citizens will be able to afford access to those platforms as more and more people become involved, as more and more industries see the value there. But for now, it's I would say that the bar of entry is as low as it's ever been. We can certainly continue to do better, but it really starts with a conversation. There's lots of information on the web pages for the ISS National Laboratory and the NASA web pages talking about projects, programs built around production applications, for example, in-space production applications or in-SPA.
Right.
And then there is tons of information from the companies themselves, Axiom Space,
Right.
Orbital Reef, that's the partnership between Blue Origin and Sierra Space, NanoRacks, and then, of course, Northrop Grumman are all prominent on the NASA pages, but there are these other companies such as Varda and Vast,
Yep.
and maybe a dozen other companies which are not only have the backing of VC funding now, but they're actually starting to fly. They're actually starting to get to low Earth orbit. They're actually starting to test if their path and their model system is perhaps offers some unique advantages to taking things to space and doing it. So it starts with a conversation. Ask the questions.
Absolutely. Yeah, we had David Zuniga on from Axiom a couple weeks ago, obviously talking about their vision for in space, and I know that you guys work with them and you support one another. But just thinking about, as you were saying, we're coming up on 2030, and then obviously things are going to evolve and transition much more towards this private model, as you're explaining. What do you want to see 2030 and beyond, Mike? If I was to give you a few $1 billion to create a space station, what are you interested in putting up there yourself? If obviously money no object, but clearly this low Earth orbit economy is supposed to be a pretty big thing, so there's going to be a lot of money thrown at it. But what do you envision 2030 and beyond that you would like to see up there, based on your own background?
Yeah. Well, I think so we're living in an era now, right, where the International Space Station is not the only game in town. China is operating a crewed station on orbit and is heavily recruiting other nations to join it in that exercise. And they're also bringing new industries online throughout Asia that can feed into that economy. So what I want to see, in the future is continued use of low Earth orbit for peaceful purposes. I would like to see the expansion of opportunities, which means new platforms that are available up there. The International Space Station has been and continues to be unparalleled in its ability to generate data to support multiple interests from multiple nations. We were able to do science that runs the gamut from quantum science. We're able to create the coldest spot in the universe up there and have insight into what the physics are like at that scale in ways that we're not able to do here on Earth, all the way through to deep space observation. The alpha magnetic spectrometer has been operating on station for going on 10 years now, looking deep back into time and space to tell us more about origins of dark matter and dark energy. And then it goes all the way down to small scale experiments where a company's interested in exploring a new process for doing thin layer deposition in microgravity, simply laying down thin layers, almost molecules thin, single molecular layers, to improve a biomedical device, right? So you have this tremendous expansion of scale and opportunity there. So in the future, I hope to see specialized facilities that are focused on these different areas. It's certainly, one of the things that I've noticed in my time on Earth is I can remember as a small child there were 2 or 3 breakfast cereals that we had on the table. Now, if I take the children to the supermarket, there are literally hundreds of different kinds of breakfast cereals that are all arrayed there.
Oh, yeah.
So offering the consumer, choice is a good thing. So in the future, there will be, different platforms operating in space that maybe cater to different audiences out there. There will be possibly hotels in space. There will certainly be facilities that can entertain visitors from Earth for short periods of time. Maybe not hotel quality, but they'll get there eventually in a few years. And most importantly, from our perspective, in thinking about creating an innovation ecosystem in space, we want to see manufacturing capabilities there. We want to certainly not repeat the mistakes of the past where we have gone in and overexploited resources and have done that to the detriment not only of the environment but of our survivability, our sustainability on this earth. But to do it in a meaningful way where we see that there are real world advantages that can offer the ability to create value back here on Earth. And that's going to require, again, a little bit of the right mix of government investment with free market enterprise to get there. So, in an ideal world, we're going to have 2, 3, or more commercial laboratories operating in space by 2030. I would love to see a LEO national lab, a low Earth orbit national lab that has access to each of those. There are certainly long-standing needs within other research agencies in the United States. NIH comes to mind first, but National Science Foundation as well, that have seen unique science returns from their access to space, and those will continue in the future. So low Earth orbit national laboratory might offer one way in order for all of that government supported research to be most effective and most cost efficient on these commercial facilities going forward. NASA will, of course, continue to be a major customer of those capabilities, but it will not be the only U.S. government agency that can derive value from access to space.
Mike, in a couple weeks, you have the 12th annual International Space Station Research and Development Conference going on in Seattle, and you and the team are going to be there. Some other folks we had on the show, like Esene at the White House, going to be speaking on space policy. What are you going to be talking about? What are you looking forward to in terms of this particular conference, in terms of networking? Obviously there's folks from everywhere around the globe showing up. Say a few words about this, because I think it's sort of the main event for this this topic.
No, thank you for reminding me of that. I'd forgotten it was coming up that quickly.
You better get there.
Now, the ISS Research and Development Conference, as you mentioned, is an annual conference. We move it around the United States. This year, we're going to be in Seattle. It's an extremely important milestone each year in that it offers us an opportunity to bring the community together. It's a very diverse community. We have multiple folks from the commercial sector who own, operate, and build the hardware that operates in space. We work with different programs at NASA, foremost among those International Space Station Program Office. So it's an opportunity to get in the same room with the folks who are responsible for the operation of the station and thinking about its eventual transition. We'll have folks there from Commercial LEO Destinations Program who are thinking about what NASA needs in terms of these commercial platforms and stations at the back end. And we'll have all of these commercial companies that are providing services and keenly interested in understanding where these new markets are going to emerge, so that they can fully utilize, that is, create even more demand for the supply that they're going to be generating on their platforms and stations. But most importantly, it's an opportunity for us to interact with the user communities. And those, again, are likewise just as broad. We work with multiple universities and small four-year colleges and trade colleges in programs ranging from STEM education and outreach, workforce development, and K through 12 exposure. There's still no marketing tool in the world anywhere that compares to the NASA meatball and the excitement that children get just thinking about space. So, we use that as the tool to kind of pry open their brains and start talking to them about things related to science, technology, engineering, mathematics, STEM. You can package all that around the excitement, they feel and have about going to space and doing that. And then, the community of industries that we work with, we'll have an array of invited talks and opportunities for technical sessions supported by the investigators, the researchers, the entrepreneurs who are currently utilizing the International Space Station, the National Laboratory, and are thinking about, how they can grow their interest in space into creating value in the future. So I had spoken earlier about, thin layer deposition and just laying down thin layers, right? We work with a company, Lam Division, which is essentially still a small startup, but they're interested in their technology is focused on making artificial retinas that can be used as treatments for advanced macular degeneration and retinitis pigmentosa. So they're able to, take their technology, which will offer a far better medical outcome than any currently accepted standard of care and treatment, and offer it more likely at lower cost or equivalent cost to the current treatments, which are not as effective as we would hope them to be. And they may be able to do that all while having to cover the transportation costs of, taking raw materials and getting their products back from space. So the conference is an opportunity to get all these folks together in one place and have just this collision of ideas and sharing about what's working, what's not working, what's going on. So it's truly a unique time for us every year. We look forward to it. We're exhausted by the time it's over. But I think everyone who attends walks away having learned something new about something they may have thought they understood completely going into it. So it's a great opportunity for us to get the community together.
Yeah, it's refreshing to see that there are still areas like this that not only bring everybody together, as you're saying, but also inspire that next generation that is going to be coming up with the new ideas and working to continue to move these various initiatives forward. It really very exciting. I just again, I've enjoyed over the years sort of reading about you and watching everything you're doing on this front. Anything else that's happening further? Obviously, that's that major conference in a couple of weeks, but anything else for 2023 that I missed that is coming up? I know you got a cargo resupply thing happening soon, but anything else on the calendar that we should know about while we have you?
Well, I just mentioned a few things which I'm sure you're aware of, but it won't going around us at about 17,500 miles an hour. But that speed pales in comparison to what's happening with the commercial crew and cargo contracts, right? We have Boeing that's going to be coming online hopefully soon with increased capability of getting crew up to the International Space Station. We have a new cargo vehicle coming online from Sierra Space. Hopefully into this year, will do its first test flight. We have this Northrop Grumman flight coming up in just a few short days. It's going to be happening very early on during the ISSRDC conference going up out of Wallops Island. But as you're aware, they're going to be changing engines. They're going to be changing launch vehicles for the Cygnus vehicle, temporarily going to SpaceX and then going to a Vulcan system. So even as we are talking about the end of life for station, there is this continuous improvement in the logistics, the transportation systems, environmental control, and life support systems. and it's all happening very quickly. We've had Redwire has been successful, in deploying more of the solar arrays, which are continuing to increase the amount of power, solar power, that's generated on the International Space Station, which offers even more opportunities for conducting science and technology development and beginning to test these manufacturing facilities that we think are going to be important in the future. And then every year we're getting closer and closer to the launch of Axiom's first habitat, which will attach to the International Space Station, begin life as a physical part of station. But over time, over the next few years after that launch in late 2025, they'll add more modules and become a free-flying system. Blue Origin and Sierra Space are working very hard on progressing from their designs to actual thoughts about assembly for their system. And they're going to offer, as you're aware, they have an integrated capability in that, Axiom is utilizing SpaceX as their transportation system.
Yep.
Through the auspices of Sierra Space, they will have their own launch capability. The Dream Chaser that's going to be launching later this year will begin with cargo capability and will eventually add crew capability as well. So there's just a lot going on. It's a very exciting time. We are truly in the midst now of a decade of results on the International Space Station, having spent this previous 20 or so years assembling it for 10 years, and then 10 years of figuring out how to work everything. We're about 4 years into this 10-year period where we can really start cranking out the data and learning even more, so that we are in a good position for the transition come 2030, where we not only understand the basics of the physics and the biology, but we're actually able to take that knowledge and spin it forward into applications that can benefit us here on Earth. So pay attention, keep looking upward, track the International Space Station when you can, and keep watching those launches. I live here in Florida. They get a little bit monotonous because they're going on all the time now, but they're still exciting. You still feel the rattle of the windows when they go up.
Absolutely. Well, I for one am rooting you on, Mike, and I look forward to. We should do another show next year as you continue to advance all these amazing initiatives and sort of championing the evolution of this space. Again, for everybody that's going to be listening to this particular episode of our show across the various podcast networks or watching on the YouTube channel, you've been listening to Dr. Michael Roberts, Chief Science Officer, International Space Station National Laboratory, Vice President, Center for the Advancement of Science and Space, enabling an amazing future for scalable and sustainable low Earth orbit economy. Mike, I want to thank you again for taking the time out of your schedule to come talk, educate us for a little while. Obviously, thank you for what you do. And as we like to say on our show, thanks for helping to create a better tomorrow for everybody via what you're doing here. Really a great story.
Ira, thank you for your time, and thank you for letting us engage with your audience today. It's not often we get to communicate in this forum, and we certainly appreciate the efforts that you put in to bringing us to your audience today.
Really great having you.